I'm Daniel from Safing.io, and I hold a bachelor's in IT security and have about 3 years of full-time Go experience in my own company. Things that happen when building a service in Go. So we're building our main product in Go, and right now that already spans 70 packages, just making it one service. And at some point, we started segregating that from one big monorepo into multiple repos, where we then decided to have 2 product repos, and then one repo we call port base, which serves as kind of a base for services in general, filled with things that we found that were not specific to our product, but were general helpers and general framework libraries that others can also use. So first we're going to go into some of the common problems you'd experience when creating a service in Go, and then we'll look at some of the things we've implemented to come about these problems. So one of the basic things you'll notice pretty fast when using multiple packages is that import loops are not so cool. So you can't just import package B in package A and then import package A in package B. It'll not even compile. So you have to somehow come around that with helper methods. For example, if you have multiple packages and they want to validate flags at some point, you kind of, just kill the application within the startup procedure, screaming that some flag isn't okay. Then that may cause some harm to whatever state there is. Clean shutdown, that's a big thing. So you want your service to come up cleanly, and then also when there's some event when it's canceled by the OS or when the server is shutting down, to also close all the files, shut down the database correctly, and that gets a bit challenging if you're using a lot of packages. Configuration changes. You don't want to just change your configuration once. You may want to change configuration while your service is running and have the change configuration take effect immediately, and not want to restart your service every time you want to change a configuration. Reacting to database changes. A lot of services have some kind of state, or most often a database in the background that saves data, and sometimes you want to wait for something to change. And of course, the fast and easy problem is to just poll the database every or so seconds or minute and just check if something changed. But that is not only slow, it also consumes resources needlessly. So we're going to look at some of these problems now with live code examples. So I've prepared some short files that we'll go through together, and I'll show you what we did about these problems. I don't want you to use just our library. You can, of course, if you want to, but I want to show you how we solve them. I want to inspire you to find your own way of doing things in Go and help you learn a couple of things. And I also hope that there's someone here that will tell me how something that I did can be done even better. I'm looking forward to that talk to you. So I'll switch to the code editor now. So, So the basic thing we use in Portbase is a modules package, which helps us structure our code in multiple segments. The basic thing that we do with our modules, we first register them to the module package. So we register a service that's called service. It has a preparation start and stop function. These kind of extend the initialization functions that Go already has. So Go has the const, the var, and the init functions. And these all run in that order. So first, all the const sections are run in all packages. Then the var sections are run in all packages. And then all the init functions are run in all packages. And then with our modules, the prep function runs in all packages. And then the start function runs in all packages. And when we finally want to shut down, the stop function runs in all packages. So we kind of extend the existing initialization procedure that Go already has. Also then, here in the back, we add 2 dependencies that this module has to make sure that these other modules are started before this one. So in our case, these are just 2 dummy modules to showcase you how this works. So I've just registered them here without any start and stop functions, but we'll see them later in the log output, how they're handled by the system. So we can go over here right now and see how this looks like. So we do go run. So you see it initiates the modules. It then starts the 2 dependencies from the service, then starts the service. You'll also see here that the logline that the service itself emits during the start procedure, then finishes starting the service module, and then tells us that it's finished starting. And when we kill it, it'll warn us, hey, I'm shutting down. And then first stop the service, and then the other 2. You may note that they started in a different order than they stopped different order than they started, because dependency 1 and 2 don't have any dependencies to each other, so their order is somewhat random. And then tells us shutdown completed and ends the log file. Let's continue. If there are any questions, please just raise your hand and ask immediately. So that I want you to follow along. I don't want anyone to drop out. So here we register our 3 modules and declare dependencies between them. The prep phase is meant for checking everything that's going on before we actually start anything. So this is mainly used for checking flags if they're correct. This is just here we just check if a flag exists, but there are flags that may have very complex meanings that you will want to check with your own custom code, and then you can do this here. The start function then actually starts the service with whatever it needs. Here we start a HTTP server, and I will explain the rest of the code that wraps this a bit later. And then we have the stop function that stops the server, in this case shuts down the HTTP server so that it waits for all the open HTTP sessions to end and then returns. So we got this. Okay, so what we're doing here, so now we looked at startup and shutdown procedures and how dependencies are handled. As an addition, each module also has its own context. So there's always a module context that also gets canceled whenever the module shuts down. So I always have a context available that I can give any function that wants it. By Go, like how the Go team thought about this is that, well, most functions that take a bit longer to do some complex things should always take a context that then it can react to when something's shutting down. So this is really easy. You can just give any function that wants a context, the module context, and it will react accordingly. let's continue with resilient Go routines. So the module system also gives us the option to start Go routines in a resilient manner. So the thing with Go routines is that whenever something panics within a Go routine, it will kill your whole service. It won't just kill that Go routine with everything. So we started not using Go function call at all, but started using wrapper services. And I can show you how these look like. These are really easy, and down here, whoops, one worker. Yeah, here it is. So that's like the core principle of what these Go routine wrappers do. They just call recover, so in the defer function, and check if there's a panic available. If there's a panic available, it creates a new panic error, which kind of beautifully wraps the panic into a nice error. It reports this error to wherever you want it to report it to. I'll come to that in a second. And then, of course, assigns the error to the so that it's returned by the function. And then down here, we just execute the given function with the module context. Going back to our example, this is the function we declare here inline, and we just call the server.listen and serve. Server is an HTTP server we defined, up here, because that's the way how you have to handle this if you want to cleanly shut down an HTTP server in Go. So we then add the listen address to the server struct and set the request handler, and then we are good to listen and serve. And whenever there's an error, we return it, except if the error is error server closed, which is emitted when we shut down the server down here in the stop method. Then it returns that, and it returns nil, telling the module that everything went well. So there are different types of these wrappers we have. So we have one wrapper for one generic wrapper, which is called just a worker. So we have module start. This is a normal worker. It's a generic worker that doesn't fit any other categories. It just starts a function in a safe context. Then we have the service worker, which starts a function, but it'll restart it with a backup timer whenever it fails, which is very convenient for things like an API listener. We want to have it restart whenever, for whatever reason, it might fail. Then we have macro tasks, which is a wrapper for very short and small but important things. So, for example, if we're handling HTTP request, we want that Go routine to be prioritized. And then, for example, I can start writing a log file or writing a config file that changed. I can wrap that in a low priority macro task, which will then be scheduled with lower priority than the important macro task. This is kind of a very simple scheduling mechanism that tries to give macro tasks with a higher priority the right to execute first. So here we just start a service worker, which means that whenever it returns an error, it will just be restarted again. Let's look at this request handler for a second. We defined this down here. For the HTTP request handlers and interface, so we need a struct with a serve HTTP method, and that is called in a separate Go routine whenever whenever a new request comes in with the HTTP server. And here you can see where we run a macro task and handle the request within this wrapped goroutine. Here you can see there's a small function built in where we can test panics. I'll show that in a second, and then we just write hello world. Let's see how that looks like when we execute it. So we run this thing. Here we have the listen flag that we saw before. And then we go here. Oops, that's small. So nope. Okay. Woo! Hello world. That works. And then we can I'm gonna check. I think we. Yeah, so we start here, and then if we call panic, we don't get anything back because it would have killed the server, but not killing it, we get a beautiful error report that in default configuration is written to standard error, and then we get a nice error log line telling us that the macro task service request handler panicked with the message test. So even though we had a panic in our service, the Go service can continue to operate, and then you can hook into whatever service you're using to get these reports shipped to. What we're going to do in 1 or 2 months is to implement a simple webhook thing so we can have these errors posted to our Slack channel or whatever privacy preserving alternative you're using. So, any questions about that so far, please?
You said do you have your own custom scheduler for the tasks?
Yes, there's yes, thank you. So the question was if we have our own scheduler for the tasks. No, so the Golang runtimes scheduler still does all the work. What we do is just we just postpone execution until there's a lower count of prioritized tasks executing.
So they get a DQ or whatever, you push them back and then.
Yeah. So yes, there's a concept of a normal task, and I didn't touch that now because it's, again, the topic, but we do have tasks that you can schedule and that you can time when they should run, but the micro tasks are just done in a very simple manner. I can actually show you that really quick. The scheduling function is down here. So scheduler. So here. So what it does is it just checks it just checks if a medium priority task is waiting, and it will just give that a go. And if nothing waiting with a medium priority, it will trigger low priority tasks, medium priority tasks, trigger log writing because we don't want to have that interfere with important tasks, and also trigger tasks if there is someone waiting for execution. So it's really simple. It just uses channels as a waiting mechanism, so it's really fast, and does some like counting here. So for here, for example, it checks if there are more micro tasks running at the moment than the configured threshold. And if there are less than the threshold, it will start triggering additional tasks. But also every task type has their own timeout. So I think medium priority tasks only wait for a maximum of 3 seconds. And if they haven't got the clearance until then, they'll execute anyway. So there's also a fallback. It won't just wait indefinitely.
Okay, but so it can't be that for a high contention, for example, that you just stop running the log?
No. So at some point it will. The log especially has its own internal mechanism. When the log buffer is full, it'll just write. Yeah. So yeah, that's covered. We want to implement like a dynamic scheduling in the future, where it kind of looks at the last minute of execution, and then sees how many macro tasks are being run, and then wait for like a lower amount. So it like adapts to your current load of the program.
Have you done any, or we can do it afterwards.
Yeah,
Maybe keep the question simple for the recording, and we can take more afterwards.
Okay, yeah, okay. So that was a small addition to the tasks. So I showed you exactly, that was where we left at with the error reporting, and we will, as I said, have this posted via webhook to our Slack similar service. So that's the main thing that we have with modules. So if we want to execute all this, we just do os exit run. Run is like the run is a package we use. It's kind of a wrapper for handling all the signals and doing stuff. It just starts all the modules, and then whenever there's an interruption from the OS, it will start a shutdown. Also, which is really great with testing, there's a flag that whenever you kill the program, it'll first print the stack trace and then start the shutdown. Or if you send the process a sig user one, so signal user one, via the command line, it'll just print the full stack of all goroutines in the middle of the execution. So whenever you have the feeling something is hanging, something is deadlocking or whatever, you can just send it to the service signal. It'll print you all the goroutine stacks to standard error, and you can inspect what's going on there. Okay, so that was the module system we were using. Let's continue to the config system, which will be a lot shorter. So the thing with configuration and services that we want to change it during runtime and take effect immediately, and also we don't want to have it easy to write. So what we've come up with is just variables that are functions, and we can do like if service enabled. What that function is just a function. These are the types available, and the function just returns a Boolean. There is no error that we have to check for, nothing. It's just return that value, and let's get on with life. How it works is that we first register a config option. We name it, we give it a key, and then we give it a description. We tell it what type that configuration option is. We also tell us that's like some extra stuff, like what expertise and release level, so what maturity does this function have, and what like how bad can you break the service if you change it. So here we have like expertise user, expertise level, expert and developer also. So if you see expertise level developer, you matter will break something if you change that. And then of course we have a default value. That's just registering the option. If you want to use it, there's this special function we also have to initialize, and we do that here. We just say config get as Boolean, use the same key as before, and then give it a default value. We now have a second default value. So the first default value will be taken if this configuration exists, and this one will be taken if that key not even exists. So there's no possibility of an error here. You'll always have a default value that can be used. And if this is really fast, and I'll show you how that works. This works by the first time we get a validity flag. So we get a flag which is a cool package called abool, atomic boolean, which is built on atomic package. So there's no locking involved here. This is really fast, and then I get the actual value from the configuration. And then I just return this function, which every time it's called, it will check atomically if the configuration itself has changed. If it has not changed, it will just return the value immediately. So whenever the configuration not change, this call only costs me one atomic check, and that's it. If the configuration has changed, I'll get the new flag to check if something changed, and I'll get a fresh value and then continue with that. So it's kind of a function that has its own cache built in. So if you don't change your configuration, there's hardly any performance impact. If you, of course, so this is only safe for one Go routine to be used. If you want to use it for multiple Go routines, there's a concurrent substruct that you can use, which then does the same thing as before, but with locking, which of course has a performance penalty, but something that's just easier to use. Or if you're doing things asynchronously, you have to do it that way. And that's what we can just here use service enabled, and there's no error that can happen, and we always know that this will work. If you ever get a configuration option doesn't exist, it will warn you with an error log line. So last package that we'll go through, and then I'll. How are we doing?
5 minutes, you're going half an hour. 5 minutes.
Okay, great, thanks. We'll just look at databases real quick, and then as these two topics are quite complex, I'm just going to showcase them to you in a finished application, development stage application that we're using in the company. So databases are a really controversial topic in Go because there's so many different ways to go about it. There's no official way to do it. There's like everyone thinks they can do it better. That's also what I thought. I'm not sure if they did it better. You can judge afterwards. Tell me if you think there's something I can do better. I'd love to hear it. So, but that's like our interpretation, what we'd like to have as a database system. So this is kind of a key value meta layer. So we're not implementing a database itself. We're using existing packages for that. It is multi-backend, so there's like one key space you can use, and you can register different backends into that key space. I'll show you right away how that looks like. Then there are hooks and subscriptions, so we can hook into a certain key space and change or do additional checks before something which is the database, or I can subscribe to a certain key space and get all the updates that change there. And then there's a beautiful WebSockets API that gives us the same functionality we see here now in Go, also in JavaScript. So here I'm just initializing a testing directory. Then I initialize the database in that directory, and then it's ready to use. What I then do is I register a new database with its key space. So the name is its key space. I give it a description, and then I select a storage type. In that case, we use the Bolt backend, which is a very nice, resilient Golang, pure Golang database. We also have backends for Badger, which is a similar Go database. FS3, which is just files and folders. A hash map, which is just a Golang map, which is in memory. And a Synco, which will never give you anything back. To access that database, we create a new interface, and then we create a test record. Like almost any database system in Go, there's some interface to satisfy, and there's a base struct you can inherit from to kickstart you in that direction. And then we can just create our record, then we set the key and we put it, and that's it. And then we can get it back. Here you see how the key works like. First, we always have the namespace, which correlates to one backend, and then we have the key, which is kind of a path-like syntax. And we can query. We'll not go into that. We hit the thing you can subscribe, you can register hooks, and you can also inject virtual databases, which is exactly what the configuration package is doing. It injects a virtual backend, which is not a real backend, it's just governed by code. And I'll show how that works right now. So here we have, okay, that's okay. I think, can you read that? Mm-hmm. Okay. So this is the application firewall that we are working on, and we have this kind of security levels, and they're saved in the database. So I can just go onto my notification thing here, change the security level to another one, and we'll see it pushed that change over the WebSockets API to a database. The application here, which is a web tech thing, also is subscribed to that same namespace, received the update and changed that concurrently. Same thing in the other direction. If I click here, we'll see it updated up here just a short bit later. Here we have a short peek at the configuration settings page. So all of the data you see here comes from the Go packages. That's the name we gave the setting, that's the description, that's the current value, and that's the default value. And then I can go here and change things and update them. And here we have the console where we can manually interact with that API. So I connect to the database, I just go query, take the config, actually I'm gonna query and subscribe at the same time to the config scope of the database, hit enter, and it'll give me all the configuration options that I have in there. And then if I go back to the settings and I go here and change one of these settings, okay, got saved. I see in the console, oh, there's an update with that database key, and here's the JSON, the new JSON that got updated. So I have live updates with the database on whatever query I subscribe. So queries can also not only touch prefixes, but also the content. I can subscribe to a certain key space when certain conditions apply. So that was a quick introduction to port base, and I'm going to finish the presentation here really quick. Whoop, play. So a short introduction. Some more information about who we are and about me. So I'm the CTO of Safing.io. I'm the lead developer of our two products. Safing was founded in 2017. Our mission is to enable online citizens to reclaim their privacy. So we're absolutely passionate about privacy. If you're too, we'd love to talk to you. We are currently funded by NetID, which is a private funding agency by the Internet Service Providers Association Austria. Then we're in the is a big incubation program, which is a program by the European Space Agency, where they, together with the country of Lower Austria, fund startups and supply technology. And we recently got a big grant from the FFG, which is the National Public Funding Agency for Innovation and Development. Our two products that we're developing in Golang are an application firewall with the codename Portmaster and privacy network with the codename Gate 17. We absolutely love talking about these products. If you're interested in them, talk to us later. They're both open source. Well, yes, they are. Gate7 is currently not on GitHub. It will be soon. And also, we are hiring a Golang developer if any one of you wants to join our company. That was it. Thank you. Are there any questions left? Do you have any ideas for me or feedback?
Thank you.
Thank you.